Hello, good morning to all my students. Okay, hopefully you have finished your MX class. Now you enter the physics class. Okay, so Yiru, good morning. Okay, Zihui, good morning. Okay, can listen me or not? Okay, so you just reply here because today I want to fast forward to start lesson. Okay, morning, Siti Khatijah, Esther, morning. Okay, how about the yesterday test? I think quite okay. What is it? Because you still can open book. Then after that, I think you can find the answer also. Okay, but I just find some student that don't know how to do the essay question. Okay, I just told you already. You need to explain first which one you need. Okay, don't choose first. Don't go to explain PQRS how the characteristic. You need to say what you want first. Finally, you go to choose, and also you need table form. Okay, I'm going to go through some of the question. I find it many of you do know how to answer the essay question. So that means that one is your 50 marks from your exam. So another 50 marks, how we get it? Okay, your project will take 20 marks because you've done two projects. So I just count the better one. Okay, another 20 is for your PPD, the homework you pass up, you got turn in or never turn in. Okay, another 10 marks about your attendance lah, your attendance for your class. So this one total up, they become 100. Okay, so this one I will tell you the finally what's your marks lah. Okay, so we go through for today topic first. So today topics from here. Okay, there's lesson 4.2. Okay, electromagnetism. Okay, that's about the induction. Again, that's the same topic, but this one is a 3. Okay, series 3. Okay, we're talking about the generator. Okay, remember for the induction, that means we're using the right hand, is it? Right hand means they never provide any current, but you need to generate the current. So that one current we call induced current. Okay, induced current. Okay, so from here we go through. Okay, direct current generator and also the alternating current generator. So we separate by two. One is a direct current, another one is called alternating current. So today lesson, I just go through to the direct current first. So from here, the wind turbine electric generator that apply the electromagnetic induction to produce an induced EMF. So from here, you can see the windmill. The windmills never provide any electricity. After that, they can turn because they turn by the wind, is it? So from the turning, so that means you must have the motor. Example, you got the coin, then you got the magnet. After that, when they're just turning, they can generate the electricity. So that one we call it as an induced EMF. So this one generator, they generate the electricity by themselves. We call it as a generator. Okay, so when you just see the word generator means we need to using Fleming right hand rule. Okay, they generate electricity. Okay, so first by DC generator. Excuse me. So that means they can produce a direct current. Okay, they also can produce a alternating current. So we need to know the step how to produce DC, how to produce the AC current. Okay, let's see. Okay, you can see the diagram here. Okay, we got commutator. Remember, we got commutator. We got carbon brush. Okay, you can see here is don't have any battery. Okay, the turning, that means you need to control by yourself. You need to turn by yourself. After that, you generate electricity until the bulb can be light up. Okay, so we go through first question. What is the function of the current generator? Okay, the current generator for what? Because you want to function to light up something, is it? So from here, the function is, there's a one of the device, they want to convert mechanical energy. So just now we called it about mechanical energy means you turn. Turn is what energy? Kinetic energy. Then you produce electrical energy. So this one is the first function for the generator. That means we never provide any electricity. We also don't have any power supply. We also don't have any battery, but you're using the motion to produce the electric energy. Okay, B, can you state the physics concept that involved in the working principle of the current generator? So the principle when I just asked about generator, you just copy from the topic name. So the topic name 4.2 is what? There's an electromagnetic induction. So this one is a principle. Okay, we're using the framing right hand. That one is a principle they're using is an electromagnetic inductions. Okay, name the two type of the current generator. Just now we show already. We got two type generator. One is a DC, another one should be the AC. Okay, DC means direct current generator. Then the AC is an alternative current generator. Okay, now we're going to see the question number 2. Okay, I think the question number 2 you also know how to do because we just label. Okay, label the structure of the direct current generator. Okay, first part, can you see 1? Okay, 1, actually, we just call it as a coin. Okay, there's a coin. Okay, after that, you see number 2. Number 2, they show about the north and also the south. So this one should be the magnet, is it? So we just call it as a permanent magnet. Okay, number 3. Okay, number 3, they point the curved one. Okay, the curved one. That one, we just call it as a commutator. But sometimes your book, they show about the slit rings. Okay, it's the same one. Okay, so that means we can say there's a one slit rings or you can say commutator. Okay, and the last one, they join the commutator and also the bulb. That one we call it brushes. Okay, it's the same thing. Just you go to replace the battery, chain become the bulb. So this one become generator. Okay, now we go to answer question B. Explain how a current generator produce the current. Okay, how come they produce the current? So that means you must say the rotation. Okay, you must have the rotation. After rotation means you cut magnetic flux. Remember, we cut by perpendicular. Okay, when it just cut by perpendicular, that means they will produce the induced current. Okay, so we need to explain that. Okay, let's see the point. You must say the coin is rotate. Okay, clockwise or anti-clockwise is depend for yours lah. Depend the situation, current, how to flow. Okay, you can say clockwise, you can say anti-clockwise. But important, you must say cutting magnetic field line or you say cutting magnetic flux. And the last one, induced current is produced. So this one is how the generator can produce the current. Okay, so you can see very clear. This one we call it commutator. You also can call it as a slit rings. Slit rings. Then side, we got two things. That one is a carbon brush. Okay, they are fixed together. Okay, which one can be rotated? Only the slit rings can be rotated. The brush is a fixed one. Okay. Okay, now we're going to see some short videos. Okay, you can see the turning. Okay, turning, that means you adjust by yourself the turning. Now it's a blue color above. Okay, blue part, the current is come to you. The current is come to you. Okay, when it just rotate, you can see when it just rotate, now it's a purple color at the top. Now the purple color, the arrow of the current also come to you. That means when it just rotate up the side of coin, the current must come to you. So that means you can find it, the rotation always in the same directions. Okay, the rotation of the coin always in the same directions. How about the outside? Outside, you can see the current. They're also moving same direction. Okay, when you're outside, you find it, the current always same direction, means that one is a direct current. Okay, so from here, maybe you say, I do know current how to flow, is it? Because we just know the force how to move. So how you know the current how to flow, we need to know Fleming right hand rule. Okay, I'll just show you the next one. Okay, we're using the Fleming right hand to find out the current, how to move. Okay, important you know how to rotate. Okay, can you see this part? The arrow at the top, blue color. Okay, this side, we roll up. Okay, another side, we roll down. So just show the video clip first. AB is up. Okay, so we just start to rotate. And using your Fleming right hand to find. Okay, AB side. Okay, now the AB is, force is up. Okay, then the magnetic field north to the south. So you can see your second finger. Second finger, the current is far away from you. Okay, so that means the current is from A to B. Okay, I think this one clear, is it? So this side AB, the current is go to AB. If I say this one is a CD, so that means your current later is from the C go to D. So I can say this round, we call it ABCD, the current flow in the coin. Okay, how about the rotation? Rotation is a clockwise. Okay, then we continue to the next part. Okay, we're going to see the explanations. Okay, we label by A, B, C, D, north and south. Okay, first one, you go to rotate because you need to move first. This one is a generator. Okay, you need to rotate by yourself first. So AB, I move up. CD, I move down. So after that, they will turn by clockwise. Okay, so after that, we're going to see the hand, your right hand. So you go point north to south. Then after that, the force is up. So where is the current? The current is far away from you. So that means the current is A go to B. Okay, another side, CD. I also can point exactly the same. Okay, first finger, I point by. Okay, number 2, the force now is go downwards. Okay, the force is go downwards. Okay, after that, the current is come to you. The current is come to you. Okay, so from here, I can show about the arrow. A, B, then C to D. Okay, after that, we go to show the explanation. The coin now is rotate in clockwise directions. AB, upwards. AB is move upwards. Then the CD is moved downwards. So that means when the question asks you how to explain the rotation of the generator, so you need to explain like this. The coil rotate how first? You need to mention how you rotate. Okay, clockwise. Then AB go where? Up. Then the CD go down. Okay, after that, what happened? After that, the Fleming right-hand rule, the current flow from A, B, C, D. Then the next, you mention current. Okay, first you mention how you rotate. Number 2, you mention current, how to flow in the coin. Okay, now we go to another part. That means just now it's a A, B, is it? Now I want to go C to D. Okay, when C go to D, that means you need to change your hand, change the position. North to south also. Okay, it's the same, north to south. Okay, after that, you see the force. Force now is go down for the DC. Okay, how about the current? Current is come to you. Come to you means C go to D. Okay, so that means if I conclude just now, A to B, then C to D. Rotate in the clockwise. So this one is a one cycle, one half cycle lah. We cannot say full cycle. This one's half only. Okay, from the flat change another flat. We can say 180 degrees Celsius. Okay, sorry, 100 degree, no Celsius. Okay, then we continue to explanations. Okay, the coin is an horizontal position. Okay, like this, 0 degree. That means when they're flat. The coin is rotate clockwise direction. So they show clockwise directions. Okay, so from here, show the direction of the coin, A, B, and C, D. So from here, they show for you already. Okay, when I just say the A, B is move upwards, then this one C, D go downwards. So you just point your Fleming right hand, then you find the current must flow A, B, C, D. So from here, we just label. Okay, we label the arrow from AB to CD. After that, when they just come out, they go to the bulb, then join the galvanometer YX. So the galvanometer pointer, how to point? They must point to the way the current come. Okay, the pointer must go to the direction where the current come. Now the current come from where? Come from the Y. Okay, in the Y, out the X. So they must follow the direction where the current in. So they go to the Y directions. Okay, so from here the question, show the direction of the coin. Then AB is what? AB is upwards. Okay, how about the CD? CD is go downwards. Okay, state the direction of the induced current. Okay, induced current direction. How? The direction is from the A to B, C to D. Then after D, they go to the Y, then go to the X, then they come back to the A. So this one's the direction, how they flow. Okay, for the coin, A, B, C, D. How about the external? External is a X to Y. Y to X. Okay, so this one's the first round. The external is Y to X. Later, we're going to see another round. Is it still Y to X or not? If always Y to X means you produce direct current. Okay, now we name the rule to determine the direction of induced current. So you're using what rule to find the induced current? Your answer is Fleming right-hand rule. Okay, so from here, what is the direction of the deflection of the galvanometer pointer? So the direction must follow where the current in. So the direction must go to the right-hand side. Okay, so this is normally the question they will ask about the generator. Okay, they ask you how they flow, then they ask you how they rotate, then they ask you how about the galvanometer go to deflected. Okay, now the coil is in vertical. Just now it's a horizontal. Okay, now it's vertical, 90 degrees. Okay, when it's just 90 degrees, show the position of the galvanometer pointer. So from here, you can see the pointer exactly. There is a 0. Okay, why? Why there's a 0? Okay, for this one situation, the problem is the magnetic field still got permanent magnet, sure got magnetic field. But the problem now, the coin is in perpendicular, not perpendicular, like straight. We call it as a vertical. When it's just vertical, we don't have any cutting magnetic flux in 90 degrees. Now you are exactly parallel with the magnetic field. So that's why they don't have any induced current to produce when they're just 90 degrees, when it's just vertical. So how about the brightness of the bulb and direction of the galvanometer pointer? So we just answer, bulb does not light up, and there's a no deflections. Okay, no deflections. So explain your answer. Why? Why the bulb cannot light up, and also why there's a no deflections. Okay, we go to see how to explain. Okay, when the coin just vertical position, the side A, B, C, D, they are parallel with the magnetic field. So you need to mention the word parallel. A, B, C, D also parallel with the magnetic field. So if parallel means no cutting magnetic field line. Okay, and the last one, no induced current. Okay, so this one is how we go to answer when the generator, when they just rotate in 90 degrees. Okay, so that means like this is nothing lah, no induced current produced from the circuit. So galvanometer deflector go back to the 0 and the bulb never light up. Okay, now I go to rotate back, continue to rotate. So continue to rotate, now you can see this part become DC. Okay, to the north pole now is a DC, to the south pole now is a AB. Okay, now the coin at the horizontal position, but coin AB and CD now they change positions. So when they just change, you can see the bulb still on already. Okay, the bulb start to on already. Okay, now show the direction of the coin. So we go to label. This one is a 180 degrees already. You turn one complete round. Okay, now the coin will still continue to rotate. DC will still rotate up, then the AB still rotate down. So that means your direction still clockwise. Okay, so from here, the current how to flow? Okay, the current still flow is the same. From here, when the DC, there's a up, the force is a up, then north, south, then you're using your framing right hand, the current still D to C. Okay, after that, B come back to the A. So now you can see the differences for the coil direction. Okay, just now the current how to flow? A, B, C, D, is it? So when I just turn 180 degree, you find it the current in the coil now is a DCBA. Okay, just the current in the coil different, but rotation still the same clockwise. Okay, so outside how to flow, we see the outside current. Okay, the outside current still the same. They come out, go to the buck. Okay, for the galvanometer, still the same. From the Y, go to the X, then come back. Okay, how about the galvanometer deflected? They're still deflected to the right-hand side. Okay, I think I forget to draw. So the student remember they still follow the where the current in. So the current in Y, that means the deflection must go to the Y. So from here, we can conclude how the current flow now in the external means the galvanometer and bulb. The current still flow YX. Agree. So don't care there is a 0 degree or there's a 180. The direction for the external still the same. So we call it as a direct current. They produce direct current. Okay, how about the current in the coil? Current in the coil memang changes already. Just now it's ABCD, but now it's a DCBA. Okay, so this one is a what differences when 0 until 180. How about the rotation? Rotation is the same, still clockwise. So this one, you don't tell me when it just rotate, normally we turn in the same direction. We never say you turn left and turn right, turn left and turn right like this. That means you cannot produce the induced current is a strong. You just produce half only. So this one is a one situation. Normally we keep rotation is the same directions. So from here, they ask you show the direction of the coin. Now the coin AB is downwards. Now DC become upwards. Okay, just now is downward, now become upwards. Okay, so we go to explain. State the direction of the induced current. Okay, now the direction induced current is a D to C, B to A. Then the A will go to find Y, then go to the X, and the last one go back to the D. So that means the direction for the internal already changed, but the external still the same. Okay, what is the direction of the deflection of the galvanometer pointer? Okay, they still go to the right-hand side. Okay, because the external never change anything. Okay, so from here we conclude just now the first cycle and also the second half cycle. Okay, first one, that means we're starting. Okay, you can see the current. Direction of the induced current is A, B, C, D. Galvanometer pointer to the right. Okay, second half cycle, direction of the induced current now is a DCBA. Okay, how about the galvanometer? Galvanometer still point to the right hand side. So that means the conclusion is external, no changes. Okay, the current still in same directions. Okay, we make some conclusion for just now the two diagram. The induced current to flow in the coil opposite directions. Okay, for the coil, okay, opposite directions. So first one is A to B, C to D. Second half, B to A, D to C. So this one is in the coil, induced current changes already. Why? Why the induced current in the coil changes? Okay, now we got reason. Okay, the reason is from the commutator. Okay, let's see the function of commutator. They reverse the direction of the current in the coil for every half rotations. So this one is a function of the commutator. Okay, the commutator will always help to change the direction for every half rotations. So that means when starting A, B, C, D, when it just turn 180, you find it the coil current reverse. So this one function from the commutator. Why the commutator want to do like this? Why they every time want to change about the half rotation, they change the current to flow? Okay, the purpose is the direction of the current in the output circuit, or you say galvanometer, always the same. Okay, they change the inside only, but the outside how? They want to maintain the outside, the current always flow in same direction to the galvanometer. So this one is a function of the commutator. Okay, they keep to make inside the coin reverse the current flow. Okay, how about the outside? Outside the current always same direction. How about the rotation? Rotation always in same directions. So that means the commutator, they want to make sure the coil turning always same directions, and also the outside external always in same direction. So this one is a function for the commutator. So that means inside how to flow the current is okay. We never see one. Okay, we just important, we want to see the external, because external you join with the bulb, is it? So that one is the external current must be direct current. So the bulb can be light up. Okay, so from here, the direction of the induced current always Y to X. So when they just put the word always, mean we understood that one is a direct current. Okay, so from here, this one we're talking about the direct current generator. Okay, let's see some different every half rotations. Okay, when it's just vertical, you can find it when vertical, then they show the induced current, there's a nothing. No induced current produced when they're just vertical, because they never cut any magnetic flux. Because now ABCD is a parallel with the magnetic field. Okay, when it just go horizontal, okay, now they start. Okay, they move from the zero up until maximum. So that means when they start to rotate a bit, so you'll find it the induced current keep increase until maximum. There's a horizontal. So from here, this one we call first half cycle. Okay, now when it just turn again, go to the vertical, so you find it, they go down already. From the maximum, they drop until zero. Okay, so from here, you find it when vertical again, no induced current. So that means now I complete one half cycle, that's a 180. Okay, if I continue to do it, just now the vertical, now I change the direction already. So I find it, they also will go up again, then go to the half maximum. Then I continue to rotate, then they finish another side. So this one where I get the induced current. This one induced current I get from the galvanometer. So you can see the galvanometer always, the direction is the same, above the graph. Above the graph means there's a direct current. Okay, they don't have any alternating current. Alternating current means positive, negative, positive, negative. But this one, when it just produce, always positive. So you'll find it, when it just plot the graph induced current versus the time, the graph is always above. There's a direct current. Okay, so this one we call one complete oscillation for the generator. Okay, 0 until 90, 90 go to 180. So 180, you continue to rotate. This one is a 270. Then we go until 360. So this one you call one complete oscillation. So we get it, direct current. Okay, so this one we call it as a direct current generator. Okay, remember when you see the word generator, we need to using right hand. And also you want to produce direct current, we using commutator, or you say slit rings. Okay, one slit rings. Okay, so we go through another part. Okay, you can see about this part. Okay, the magnetic field. Okay, you can see how they just start to flow. When up, okay, when it turn, 90, when they're up again. So you see they always the outside. You see, you observe the outside current. The current always in same direction. So it's a direct current. Okay, so this one is one of the diagram to show you how the direct current to produce from the generator. And also you can observe the rotation of the coil always in same directions. Okay, always in the same directions. Okay, so today lesson just only shorts. Okay, what you need to do, I already upload in the Telegram. Sorry, not Telegram. There's a Google Classroom. Okay, Google Classroom. This one of the exercise. Then this one exercise you need to do now. Okay, you go to the Google Classroom. After that, you go to download, or you can straight to do as they. Then after that, it's the same. Snap photo, upload, turn in. That one is today attendance. Okay, today I never do any Google form. So what you need to do, you need to turn in to prove your attendance is there. Then this one is a PBD for 4.2 electromagnetic induced current. Okay, so this one just only short question, one question only. Okay, about 2 pages. So you can straightforward to answer and also turn it. So our short lesson just until here. So hopefully the next week I can finish to marking your paper and discuss with you the answer. Okay, so our lesson just until this part only. So you can start your work to do the Google form, the Google Classroom, the exercise, and turn in as your attendance. Okay, Ling Han, thank you. Thank you every student to watching. Okay, you can start your work. Bye.